If you picture Sardinia, you probably picture Italy with a coastline, a rugged island off the western edge of the Italian mainland, close enough to reach by a short ferry ride. You picture red-orange cliffs, sheep grazing on scrubland, a village festival with accordion music. And somewhere in the back of your mind, a quiet assumption sits underneath all of it, that the people who live there are, genetically, just Italians. Italians who happen to live on an island instead of the peninsula. It seems obvious. Sardinia sits inside Italy's borders. It shares Italy's language, Italy's cuisine, Italy's flag. So the DNA underneath all of that should look Italian too. Close enough to blend in. Close enough that a geneticist glancing at a chart would place Sardinia right where the map says it belongs, tucked in beside Rome, Naples, Palermo. That is the picture most people carry. It is also, as it turns out, almost completely wrong. Geneticists noticed the problem decades ago, long before most people had heard the word genome. Every time they plotted European populations on a genetic map, Italians clustered together. The Spanish clustered together. So did the French, the Germans, the Greeks. Sardinia did not. It kept drifting off to one side, alone, refusing to sit near anyone. That single stubborn dot on the chart quietly rewrote the question. Not, are Sardinians different? Something narrower. Out of every population geneticists could test, on any continent, which one actually matches Sardinian DNA? Not close. Matches. Answering that question meant comparing genomes the way you'd compare fingerprints, at a scale most people never think about. Modern DNA studies do not look at one gene. They look at hundreds of thousands of genetic markers at once, sometimes millions, and measure how far apart two populations sit across all of them. Researchers plug that data into massive reference panels, projects like the Human Genome Diversity Panel and the Human Origins Array, both of which include samples from Sardinia, sitting alongside hundreds of populations from every inhabited continent. In theory, the tool to answer this question has existed for years. In practice, it kept failing. Early studies from the 1990s and 2000s used a few hundred markers at most. Too coarse, too blunt an instrument to catch a signal this specific. And there was a second, bigger problem. You cannot find a population's true match using only the living. You need its ancestors. For most of genetic history, ancestors were unavailable, buried, degraded, unreadable. That changed in 2012, when scientists successfully sequenced the full genome of a 5,000-year-old body pulled out of the ice in the Alps. The tool nobody had was suddenly sitting in a freezer. Before the comparison could mean anything, researchers had to widen the field first, because the obvious answer is rarely the whole answer. Take the Basques, tucked into the mountains between Spain and France. They speak a language linguists still cannot connect to any other tongue on the planet, a total outlier, and geneticists have flagged them as an outlier too for decades. Or the Kalash, a small community in the mountains of northern Pakistan, who tell a local legend that they descend from soldiers left behind by Alexander the Great roughly 2,300 years ago. Geneticists have studied them for their isolation, not their myth. Then there are the Orcadians of Scotland's Orkney Islands, carrying a genetic mix of Viking and Pictish ancestry from Norse settlers who arrived around the 9th century. Malta tells a messier story, layered with Phoenician, Sicilian, and North African contact stretching back 2,500 years. And Iceland, famously mapped down to the individual by geneticists at Decode, descends from a founding population of Norse settlers and Gaelic islanders from roughly the same era as Orkney. 5 islands, 5 isolated peoples, 5 entirely different histories. None of them, it turns out, is where this story is going. But you cannot understand why Sardinia stands apart until you see how many other candidates could plausibly have been the answer. There is a rule in population genetics that usually holds. Distance predicts relatedness. Populations that live closer together tend to share more DNA because for most of human history, people married the neighbors, not strangers 3 countries away. Sardinia's nearest neighbor is Corsica, separated by a strait of water barely 11 kilometers across, closer than some people's daily commute. Under that rule, the prediction writes itself. Corsica should be the closest match. If not Corsica, then mainland Italy, just across a wider stretch of the same sea. Geography said the answer was practically within swimming distance. Geography said the answer was practically within swimming distance. Geography said the answer was practically within swimming distance. Geography said the answer was practically within swimming distance. Geography said the answer was practically within swimming distance. Geography said the answer was practically within swimming distance. Geography said the answer was practically within swimming distance. Geography said the answer was practically within swimming distance. Sub-Saharan African and East Asian populations dropped out of contention almost instantly, and nobody was surprised. Humanity's deepest genetic split runs through Africa itself, tens of thousands of years old, older than agriculture, older than cities, older than almost anything we'd call history. Some hunter-gatherer groups in southern Africa carry more genetic diversity among themselves than the rest of the world's population combined. One population, more variation than everyone else on Earth put together. Next came the Pacific and the Americas, separated from Europe by ocean crossings and land migrations that unfolded over thousands of generations. Too distant, too divergent, gone in an instant. Closer to home, modern Middle Eastern populations looked like reasonable candidates on paper. Anatolia, after all, is where European farming began. But modern Anatolia is not ancient Anatolia. Waves of Turkic migration swept in from Central Asia starting around the 11th century, reshaping the region's genetics long after Europe's story had already split off. The population living there today carries a different signature than the one that mattered 8,000 years ago. Eliminated, and for a genuinely interesting reason. Then Northern and Central Europe, the British, the Scandinavians, much of Germany. These populations carry heavy doses of what geneticists call steppe ancestry, DNA traced back to pastoralist migrations that swept out of the Pontic steppe starting around 3000 BCE. That migration didn't just add new genes to the mix. In parts of Bronze Age Europe, it appears to have replaced huge swaths of existing male lineages within a handful of generations. A demographic event, not a blend. Northern Europe absorbed it fully, eliminated. Sicily and Malta came next, and they lasted longer, geographically plausible, culturally Mediterranean, but both islands were reshaped repeatedly over the last 2,500 years, first by Phoenician and Punic traders, later by Arab and Norman conquest, too much later admixture layered on top, eliminated, which left Corsica, 11 kilometers away, the predicted winner from the start. And Corsica does share history with Sardinia, but its population absorbed more continuous contact with mainland Italy and France over the centuries than Sardinia's interior ever did, close on the map, not close enough in the genome. Eliminated, and the nearest candidate was gone. One population remained standing longer than any other, the Basques. Studies tracking shared stretches of DNA, the kind of long, identical segments that only appear between closely related groups, found real overlap between Basques and Sardinians. Real, but partial. A cousin, not a match. Every living population on Earth had now been tested, and every single one had failed. That should have been the end of the search. Every candidate ruled out, every reasonable guess exhausted, and still no answer. So researchers changed the rules of the comparison entirely. Instead of testing only the living, they added the dead. Genomes recovered directly from ancient bones, pulled from burial sites in Germany, in Hungary, in Spain, in Sweden, and from one frozen body found in the Alps. The moment those ancient genomes entered the panel, something in the data shifted. Not a small adjustment, a sharp pull, all in one direction. The distances that had stayed stubbornly wide for every living population on the planet suddenly collapsed. The closest genetic match to a modern Sardinian was not a nation, it was not a neighboring island, and it was not a language isolate in the Pyrenees. It was a man who died roughly 5,300 years ago in the mountains between Italy and Austria, and the farming communities like his that spread across Europe starting around 8,000 years ago. His DNA matches Sardinian DNA more closely than any living population does. Not the Basques, not the Corsicans, a frozen body, and the farmers he came from. That answer sounds tidy, almost like a curiosity. A modern population happens to resemble one ancient mummy, but that framing misses what actually happened, and it misses it badly. Ötzi was not a random individual who happened to leave behind good DNA. He belonged to a much larger population, farmers descended from Anatolia, who spread across the entire European continent, starting 8,000 years ago, carrying agriculture with them, from Greece to Germany to Iberia. For a few thousand years, their ancestry was Europe. Almost everyone on the continent traced back to them. Then it started disappearing. The steppe migrations of 2900 BCE overwrote huge portions of that ancestry across northern and central Europe within a matter of centuries. Later movements, Iron Age expansions, Roman-era mixing, medieval migrations, kept diluting what was left, generation after generation, region after region, until that original farming population's genetic signature had been buried under layer after layer of newer ancestry almost everywhere it once existed. Almost everywhere. Not Sardinia. Protected by open water, and later by a rugged, hard-to-reach interior in its central highlands, the island simply never absorbed those later waves the way the mainland did. Estimates suggest Sardinians retain something close to 90% of that original farming ancestry, the highest of any living European population, by a wide margin. Which means the story was never really about a resemblance to one man in the ice. Sardinia is not a population that happens to look like an ancient ancestor. Sardinia is the last place on Earth where that ancestor's genome never actually left. The genome comparison did not stand alone. In 1991, two hikers in the Ötzi Alps stumbled on a body frozen into the ice, a discovery that had nothing to do with statistics or reference panels. Archaeologists dated him independently, using the physical evidence around his remains, and landed on the same window the geneticists would later confirm through DNA, roughly 5,300 years old. Two separate methods, one answer. Sardinia's own archaeological record tells a matching story. Starting around 1900 BCE, its people began building nuraghi, squat stone towers that still dot the island today. Roughly 7,000 of them. Construction continued largely uninterrupted for more than 1,000 years, into the Bronze Age. That kind of unbroken building tradition points to a population that stayed put, generation after generation, rather than one repeatedly replaced by newcomers. The genetics say the same thing in a different language. Even medicine backs it up. Sardinia carries unusually high rates of inherited conditions like thalassemia and G6PD deficiency, the kind of pattern that shows up specifically in populations that stayed genetically isolated for a very long time. 3 different fields. One conclusion, arrived at 3 separate ways. The numbers make the isolation concrete. Hawke and colleagues estimated that modern Sardinians carry roughly 90% ancestry from Europe's first farmers. Compare that to most of Northern Europe, where later steppe migrations pushed farmer ancestry down to a minority share of the genome overwritten by newer arrivals. 90% against a fraction of that. Not a small gap, a different category entirely. Diet tells a related story. Across much of Northern Europe, the ability to digest milk into adulthood, called lactase persistence, became common, a genetic response to generations of steppe-descended dairy herding culture. In Sardinia, that same trait stayed rare, closer to the original farming population that never fully adopted the habit. 2 populations, 2 different digestive inheritances, same split, written in a completely different system of the body. Genes for immunity, genes for digestion, genes with nothing to do with each other, all pointing back to the same 5,000-year fork in the road. If you have ever eaten Sardinian pecorino, made from sheep that graze the same highlands that sheltered this ancestry for thousands of years, you have tasted a small piece of that isolation without knowing it. Every glass of milk a Sardinian body struggles to digest carries a trace of a habit their ancestors never picked up. Every stone tower still standing on that island was built by descendants of people who simply stayed. Scientists set out to compare one island's DNA against every population they could find, living and dead, and the only real match wasn't a country at all. It was a 5,000-year-old ghost that never actually left.